Okay, imagine you're making some soft drink. You take some water, you add sugar to it, you add some flavor to it, and you add the special fizz by adding some carbon dioxide gas into this liquid. Now that you have this cold drink ready, you make a nice bottle and you label it with whatever you want your soft drink to be called, and now you want to send it to your friend sitting in Kerala, but you're sitting in Meghalaya and it's a really long way, right? So you're sending it all the way to Kerala, but the problem is there'll be a lot of temperature change, and one important part that will be ruining your cold drink is bacteria. Bacteria loves sugar, it loves to feast on sugar, so it's going to ruin your cold drink and nobody will be able to drink it. Now what you need to add is preservative, right? So when you go ahead and do your research about preservatives, you realize that preservatives are pH sensitive, you realize that preservatives are temperature sensitive as well. So you start this entire process of researching, and after a point you realize that you have this compound that you've been looking at a lot of times in your chemistry books called benzoic acid, one of the most common compounds that can kill bacteria, right? So now you understand that you need benzoic acid and you just needed to add it into water, and then add some sugar, then add some flavor, then add some fizz, and voila, you're done. But no, there's a small problem. The problem of solubility. Benzoic acid does not mix in water, so you need something else. But no, you don't need to do something else. That's the fun part of being a chemist. You can manipulate this compound to be mixed in water and still somehow use it as preservative. Let me tell you what I mean exactly. So you have benzoic acid, which looks like this, and you need to mix it in water. Water does not dissolve it because water is a polar solvent and benzoic acid is not polar. What you need to do is that you need to ionize it. You need to make a salt out of it. So you make it react with some salt. Maybe we're going to use baking soda, and we're gonna make a salt out of it. We're gonna make COO negative, and we're gonna replace the H with Na, sodium. This compound is soluble in water and you're done. Your problem is solved. Doesn't work as bactericide. It was benzoic acid. So what do? Wait, chemists can do a little bit more than this. We're going to replace this H as we were doing before, and we're going to replace it with sodium, right? And now, because cold drink has some CO2 in it, it is a low pH solution. It has a pH between 2.00 to 4.00, right? Which is where benzoic acid shines. This is exactly the pH where benzoic acids work. What you're going to do is that you're just going to add it to your cold drink, where there will be some free H plus ions which will want to convert it back to benzoic acid. Hey, so now your job is done. You have a preservative, you have your fizzy drink, you just mix them all together and you send it off to Kerala to your friend. They can enjoy this really tasty and no bacteria cold drink. But did you know how we all know this? Because we studied acidic strength of organic molecules. So in the next videos, we're going to study how to find acidic strength of organic molecules. See you next time.